Welcome to our presentation on mastering data import and export in Stata. This is a crucial skill for any economic researcher. We will cover a comprehensive workflow that forms the foundation of reproducible research, ensuring your work is transparent, verifiable, and efficient. Data preparation is not just a preliminary step, it is the foundation of reproducible research.
Real-world economic analysis rarely involves a single, clean dataset. We often need to integrate data from disparate sources, like Excel spreadsheets, CSV files, SQL databases, and even legacy formats from SAS or SPSS. The key insight here is that reproducibility starts at ingestion, import process. This creates a transparent and verifiable pipeline that others can follow to replicate your results.
The first step in importing data is to check the file extension, which guides you to the correct Stata command. For spreadsheets like .xls or .xlsx, use putexcel. For text or CSV files, .csv, .txt, import delimited is highly recommended for its versatility and compatibility across Windows, Mac, and Linux. And you can also use infile for fixed formats. Stata also supports importing directly from other statistical software formats, using commands like import SAS, import SPSS, and import dbase. For modern big data formats, specifically Parquet, use import Parquet. Remember, Stata 1819 offers robust native support for almost all major data formats, including efficient columnar formats like Parquet for large datasets. For connecting to databases, Stata uses ODBC, Open Database Connectivity, and JDBC, Java Database Connectivity. These are industry standards for interacting with SQL databases. The most powerful feature of these connections is server-side filtering. Instead of downloading a massive 50-gigabyte table, you can use an SQL query to pull only the specific rows and columns you need, which saves immense time in memory. Stata also has built-in commands for popular economic data APIs, like the Federal Reserve Economic Data, or FRED. The import FRED command lets you download series like GDP or CPI directly into Stata without ever opening a web browser. Instead of downloading all transaction data for the last 20 years, you could use an SQL query within Stata to fetch only the sales data for the fourth quarter of 2023 for a specific region. This is the essence of server-side filtering. Now that we know the main command, let's break down the universal structure of Stata syntax to understand how they work. Here we see two basic import commands. The first uses putexcel to load data from a specific sheet in an xlsx file, in this case, gdpdata.xlsx and sheet 1. The second uses import delimited for a .csv file, specifically uswages.csv. Both commands use the clear option, which is mandatory if you already have a dataset loaded in memory. One of the most critical options for both is first row. This tells Stata that the first row of your file contains the variable names, not data points. If you forget this, Stata might misinterpret your numeric data as text or string variables because the header, e.g., year, is text. For example, if your CSV file has headers country, GDP, year, using the first row option ensures Stata creates 3 variables with these names. Without it, Stata might name them A, B, C, and treat country, GDP, and year as the first observation. Failing to use first row can lead to numeric columns being incorrectly classified as strings, preventing mathematical operations. Stata can interact directly with RDBMS, relational database management systems, like Oracle or MySQL. This is essential for working with large, corporate-level datasets. ODBC is a long-standing standard, but often requires system-level configuration, which can be tricky depending on your computer's permissions. JDBC is a newer, cross-platform alternative that works consistently across Windows, Mac, and Linux. This makes it much easier for teams with different operating systems to collaborate using the same scripts. The main advantage of both is minimizing network traffic by using SQL to filter data on the server before it even gets to Stata. The code ODBC load exact select ID wage from employees where year equals 2023 DSN corporate DB doesn't download the entire employees table. It executes the SQL query on the database server, and only the ID and wage for the year 2023 are sent over the network to Stata. Importing data is usually smooth, but there are a few critical pitfalls you must be aware of to avoid serious errors in your analysis. First, be mindful of encoding issues. Modern Stata uses UTF-8, but older datasets might use a different encoding, causing special characters like accents to display incorrectly. The Unicode translate command can often fix this. Second, and more dangerous, is the infinity trap. In Stata, a standard missing value, represented by a dot, is treated as positive infinity. This means it's the largest possible number. This has a critical implication. A condition like if income greater than 1,000 will be true for missing values. To avoid this, you must always explicitly exclude missing values from your conditions using the isMissing function. The ampersand means and. Most data commands follow a logical structure. It starts with the action, which is the command itself, like import or describe. Next is the source, typically specified with the using keyword, followed by a file name or a database connection string. This tells Stata where to find the data. Finally, we have modifiers or options. These come after a comma and tell Stata how to perform the action. This is where you specify details like which sheet to import from an Excel file or how to handle the first row. For example, in the command import delimited using data.csv clear, the action is import delimited, the source is data.csv, and the option is clear. These options are incredibly powerful. Let's look at some of the most essential options you'll use in almost every import task. The clear option is mandatory if you already have a dataset loaded in memory. It tells Stata to replace the existing data with the new data you're importing. Using case lower is a crucial best practice. Stata is case-sensitive, meaning variable and variable are treated as two different things. Converting all variable names to lowercase upon import prevents variable not found errors later on. The sheet option allows you to specify which worksheet to import from an Excel file. Without it, Stata will only import the first sheet by default. Finally, row range is useful for skipping metadata or footnotes at the beginning or end of a spreadsheet, allowing you to import only the rows that contain actual data. If an Excel file has an introduction on sheet 1 and the data on a sheet named Q4 data, you would use the command import Excel using report.xlsx, sheet Q4 data, clear. Let's see how these options work in practice with the two most common file types, Excel and delimited text. Our scenario is importing a raw CSV file named uswages.csv. The very first step in any script should be to set the working directory using the cd command. This tells Stata where to look for files and where to save output, avoiding the need to type full file paths every time. Next, we use the import delimited command. We include the clear option to ensure Stata's memory is empty and case lower to standardize our variable names from the start. You should also use the preview window to visually check that delimiters, such as commas or tabs, are correctly detected. Immediately after importing, you must verify the data. The describe command is your best friend here. It shows the storage type of each variable. The summarize command gives you key statistics like mean, min, and max, which is a great sanity check. Do the minimum and maximum wage values make economic sense? A common red flag is seeing a variable that should be numeric stored as a string, like wage being str10 here. This often happens if the column contains non-numeric characters, like $signs or commas. You cannot perform mathematical operations on a string variable. The problem we often encounter is that a numeric variable, like wage, might be imported as a string because it contains non-numeric characters, such as $signs and commas. You cannot perform mathematical operations on a string variable. To fix this, we use the dstring command. The dstring command converts a string variable to a numeric one. We use the replace option to overwrite the original string variable with the new numeric version. Crucially, we add the ignore $sign commas option, which tells Stata to simply ignore any $signs or commas it encounters during the conversion process. This is a powerful and efficient way to clean messy numeric data. After cleaning, we can now perform mathematical operations, like creating a new log-transformed wage variable using the generate command, as shown with generate ln wage equals ln of wage. The before and after example visually demonstrates how a string like $sign 50,000 becomes a numeric value 50,000. After cleaning your data, the final crucial step is exporting your results. On this slide, we illustrate two primary ways to save your clean data, one for internal Stata use and another for broader collaboration. First, for your own project or when sharing with other Stata users, always save your dataset in Stata's native .dta format using the save command. This is vital because the .dta format perfectly preserves all metadata, including variable labels, value labels, and other essential characteristics that ensure your data remains fully interpretable within Stata. We use save cleanwages.dta, replace to create or update this master file. Second, for collaborating with colleagues who may use different software like R, Python, or even just Excel, exporting to a universal format like Excel's .xlsx is best. The command for this is exportexcel. The sharing protocol on the right emphasizes this. Use .dta for Stata users and .csv or .xlsx for general distribution. When exporting to Excel, a critical option is first-row variables. As highlighted in the tip, this option ensures that your Stata variable names are correctly written as the column headers in the first row of your Excel spreadsheet, making the file immediately usable for others without manual renaming. In summary, a reproducible workflow consists of 4 key stages. First, ingest your data using scripted commands like import or ODBC. Second, verify the data immediately using describe and summarize to check for errors. Third, clean the data by fixing issues like string variables using dstring and creating new variables with generate. Finally, export the clean dataset using save for Stata format or export for universal formats. Mastering this process is essential, as good data management is the majority of the work in any analysis. As the